Hello wonderful person, this is Anton, and in today's video we're going to be talking a little bit more about the amazing discovery of Proxima Centauri b, the exoplanet that is closest to us and possibly might be our new home in the future. In this video we're going to talk about some of the new findings as of September 2016, and we're also going to talk about everything we know about it and some of the speculations we have about it, including using things like Eyes on Exoplanets by NASA, which you see in front of you, and also using the Space Engine. Anyway, if you haven't subscribed yet, click that subscribe button right now because there's so many more videos coming in the future. Welcome to What the Math. So this right here is Eyes on Exoplanets, and this is what we're going to be using. If you go into the home here, you'll actually get all of the highlights, and interestingly, 3 of them have a Star Wars reference. I don't really know why, but it says, hey, this planet is like Hoth, this planet is like Camino, and this is like old Coruscant. Is it Coruscant or Coruscant? I think it's Coruscant. Anyway, but what we actually want to look at is right here under latest discoveries, Proxima Centauri, August 2016. We're going to zoom into it and let's take a look at it from the perspective of what NASA thinks it may look like. So this is probably the best sort of theoretical orbit that we have of this particular exoplanet right now, and this is actually Proxima Centauri. Let's actually take a look at it first. We're going to zoom in here, or we can actually just click Star View. And this is what the star is probably, or kind of looks like. This is something known as a flare star. It's basically a red dwarf that has a tendency to spew out a lot of radiation once in a while. This is why it's called a flare star. And then we have a planet here that is probably the most exciting discovery in the last few years. This is Proxima Centauri b, and Proxima Centauri b is an Earth-like exoplanet that we know very little about, but we know it is definitely there. The current chance of it not being there is something like 1 in several million. So you're actually more likely to win a lottery than to not have this planet out there. That's how unlikely that this is just a fluke. Now, this particular simulation doesn't really simulate planets very well. It just sort of shows you the basics and some of the basic information here. You can also actually take a look at the habitable zone, and you can see that this planet is actually in it. With some part of it being maybe somewhere outside of it, but for the most part it's actually in the habitable zone, meaning that there's a high chance for having liquid water. You can also do this, and it shows you how long it takes to travel, 4 light years away, 4.2 specifically. If you were to fly it on a jet airplane, it would take you something like 5 million years. So that's pretty far, right? Anyway, oh yeah, and a car, something like 47 million years. So don't try to drive there. It's going to take you a while. Let's see what this planet looks like, though. I actually want to zoom into it. And so this is what the speculative view of it is compared to other planets. And this is, of course, just a sort of artistic speculation of NASA. This is what they think they might look like. It's all red. It has very interesting colors. But that's really all we know about it. So we're going to go into Space Engine and talk about some of the other discoveries we have about it. And here you can actually increase the rotation rate just to see what it looks like if it spins. Unfortunately, Eyes on Exoplanets doesn't really provide you with a very good detailed view of the surface. This is where Space Engine comes in. So let's actually talk a little bit more about Proxima Centauri b while we fly through the Proxima Centauri system in Space Engine. Now, once again, this is actually all procedurally generated, so it's not exactly how it looks like. But in one of the on one of the planets here in this particular system, there is actually life, and we're going to go and check it out in a few seconds. Now, so what exactly have we found out as of September 2016 about this beautiful planet that is actually out there? Well, first of all, one of the most exciting things is obviously the fact that it's the closest planet to us, the closest exoplanet to us, and it does have a very, very high chance for habitability, meaning that we can actually one day maybe settle on it and create some sort of a colony. However, it is not the best candidate because we have actually found quite a lot of other exoplanets that seem to have better size or better location in relation to the star, and so maybe, just maybe, Proxima Centauri is not the best place for us, but it is a pretty exciting place because of the mass and because of the fact that it's actually in the habitable zone of the Proxima Centauri star. But unfortunately, until we actually find a way to get more characteristics of this particular planet, we won't really be able to find out more about whether it's Earth-like or whether it's some sort of a tiny gas giant, or if it's something completely different. And one of the best ways for us to discover more about this particular planet is to launch the so-called Starshot project, which was planned by Stephen Hawking and, of course, the Facebook founder Mark Zuckerberg and a Russian billionaire by the name of Yuri Milner. They've been planning this mission for quite some time now, and what they're planning to do is launch these really tiny satellites using really powerful lasers that will try to accelerate these tiny satellites to the fifth of the speed of light, meaning that they'll be able to get to Proxima Centauri in just under about 25 years. But this mission is still being planned, so it will actually take a few years to even try to come up with the actual lasers and the actual satellites needed for this type of a mission. Alright, so anyway, so let's talk more about the planet. And I guess the first thing is that we are absolutely certain that it has a minimum mass of about 1.27 masses of Earth, meaning that it's about 27% more massive than Earth. But it might be as much as 3 masses of Earth because we're not exactly sure of its orbital inclination. Depending on the inclination that it has, it might actually be more massive, but definitely not more massive than 3 masses of Earth, meaning that it is going to be very likely some sort of a rocky planet with rocky composition, and in that case the radius would be maybe 10 to 20% bigger than the radius of Earth, with a relatively similar gravity as well, and the average temperature of approximately at least minus 40 degrees Celsius or minus 40 degrees Fahrenheit to much hotter if there is a lot of atmosphere. But the coolest thing about this star is that it's obviously in the location where we can technically have liquid water. This is called a habitable zone. And here, this is where it gets really interesting, because depending on how the orbit is and depending on whether this particular planet has a magnetosphere, it may or may not have liquid water. But let me actually go into a little bit more detail so you can kind of understand why exactly we're not really sure whether there is water here. First of all, Proxima Centauri is actually known as a flare star, a concept about which I'll be talking about in one of the future videos, but basically it's a star that once in a while spews out a huge amount of energy that may actually strip a planet of atmosphere and water if there's no magnetic protection, if there's no magnetosphere. So Earth would actually survive it quite easily because our magnetosphere is pretty powerful. Jupiter as well, because Jupiter has the most powerful magnetosphere in our solar system. But a planet like Venus or a planet like Mercury or even Mars would lose all of its atmosphere and of course water as well within a few million years if this was actually, or if our sun was actually a flare star that had the same kind of effect. And because of this really high energy emissions, it's also very likely that this particular planet might actually not have any atmosphere at all on it. It might have actually been completely stripped away, once again, if it doesn't have magnetosphere or some kind of a protection from this radiation. And because this planet is so close to its star, basically here the orbit is only about 11.2 days in comparison to something like 80 days or 86 days for Mercury. This means that there's quite a lot of radiation that it does receive, but because the star is much smaller and also much less powerful than our sun, this is actually something called a red dwarf. Here the amount of light that it actually receives, or at least visual light, is something like 2% of light on Earth, meaning that if you look into the skies, you'll basically always see very kind of a twilighty starlight, which would obviously make this planet kind of dark. But it does receive quite a lot of amount of infrared radiation and something like 400 times X-ray radiation. This is way more than Earth. So in this sense, this planet can kind of be a little bit dangerous to live on, once again, if it doesn't have magnetosphere. Yeah, so it doesn't receive a lot of light, so it's kind of dark, but it does receive huge amounts of infrared radiation, which makes it kind of warm. And of course, it does receive X-ray radiation, which can actually kill a lot of things if they were to live on this planet and if there was no protection. The other thing about this planet that can actually possibly make it not habitable is of course the fact that it's very likely to be either tidally locked, meaning that one side is always facing the star, or locked in a resonance similar to Mercury. Our Mercury has a resonance of 2 to 3, basically for every 2 orbits it spins 3 times. And so this particular planet might actually have the same. So it might be spinning really slow, or maybe it doesn't spin at all and actually always faces the sun or the star. And in that case, it might be very difficult to live here because one side is always hot, one side is always cold, and only the so-called terminator area, basically the line between the darkness and the light, would be actually kind of habitable, and where we can also possibly have some kind of liquid water too. But all of this, of course, depends on the atmosphere. So if this planet has no atmosphere and if it's tidally locked, it would be impossible to live here. If it has very thick atmosphere that mixes very well, it might actually have a really comfortable temperature everywhere on every side, including the dark side. But in order for us to have this atmosphere, once again, we need to have magnetosphere, a very powerful magnetosphere, to protect from all of these flares of Proxima Centauri, because otherwise all of this atmosphere would eventually disappear and get pushed out into the outer space. And of course, without this magnetosphere protection, water would also be very likely pushed out into the outer space and completely evaporate from the surface, unless of course there's some kind of a mechanism that protects it from being evaporated. But according to the simulations that were run about this planet, it's very likely that a very large amount of water has actually been lost, so maybe, just maybe, this is actually a very dry planet. But this is of course assuming that there is no magnetosphere, or the magnetosphere is not very strong. If however this does have a magnetic field, and if it does actually have some sort of a protection from these flares, then the liquid water may actually be only present in the sunniest regions, or possibly in the terminator area, but definitely not on the dark side, because this dark side would be too cold for this planet to actually have liquid water. And if this planet actually has a very Mercury-like resonance of 3 to 2, meaning that it spins 3 times for every 2 orbits, this means that every 6 or 7 days the liquid water actually freezes, and then it melts again. And that's of course assuming there is water on the planet, but it would be a very interesting place to visit, because here you go from liquid water to ice every few days because of the way that it's positioned and because of the way that it rotates around its parent star. But the other really unusual thing about this particular planet is that it doesn't seem to meet any kind of models that we currently have for the planetary formation around smaller stars, or even around stars like the Sun, because it is really massive for an object to be so close to the star. So either it came from somewhere completely different, or it was formed in a very unusual way, or it has actually been dragged closer to the star where it is now, meaning that it's very possible that in the beginning it was actually farther away from the star and maintained a lot of its water, and then as it moved closer to the star, it may have actually developed some sort of a magnetic field, and now it's actually in the habitable zone of the star, which of course gives us quite a lot of opportunity for this to actually be not only a habitable planet, but possibly even have some sort of life on it, because if it came from a different region and then moved closer to the star, maybe this is when it actually warmed up and things have developed into something that we can call life today. But anyway, so that's all we currently know about this particular planet and star Proxima Centauri. I'm sure in the next few years we'll discover a lot more, because a lot of scientists are very excited about this right now. And this is probably one of the biggest discoveries of this decade, if not this century so far, because not only have we found a very interesting exoplanet, but it's actually the closest exoplanet, the closest star to us, and a location that we might actually potentially visit this century if everything goes right. And we might even still be alive and talking about it in a few years from now. Not few, but sometime in the future. Anyway, so that's all I wanted to say about Proxima Centauri b, and hopefully you learned something from this video. Do check out Space Engine because it's a free simulation, and also give NASA's EYES a try because it's a pretty awesome simulation as well, and it's also free as well. And I'll see you guys in the next video. Subscribe if you still haven't. Share this video with your friends or someone who you think might like these videos, and I'll definitely consider making more in the future that will talk about various planets that we discover. And I'm definitely looking forward to talking more about Proxima Centauri b in the future. Thank you for watching. I'll see you later. Bye bye.